Let's all welcome Dr. Hans Kandel. Yeah.
Okay. Good morning, everyone. So today I'm going to cover just a smorgasbord of some of the topics. I'm working for the Extension Service, so we are talking a lot about soybeans in front of various farmer audiences. I'm based here on campus, but I'm covering the state and do some of the work in several parts of the state. So I'm just going to highlight a couple of things today. I'm using a couple of papers that came out this year on several topics that I've been researching. So the first topic I want to talk about is we did some research on ridges. And you can see here on the left, there is a small plot type of equipment that we made to ridges. So why ridges? Well, in the East, we have had many years where we have excess moisture. So if you can make ridges, you can plant the soybean out of that saturated zone. So that would be a way to alleviate some of the stresses that are due to excess water. So here's a picture of the flat area and of the ridges. So it was in a split plot. We had 8 reps. And the point that I want to make here is if you look here at the picture, you see a little bit of shining soil. That means there was some excess moisture. And if you look here at the population, you can already see that in the normal situation, you get a reduction of your stand if you have saturated conditions. Whereas on the left, you see the ridges, there are more plants established there. So I'm just only giving the highlights today of several topics. So here a table comparing the yields and the plant population. So flat, as I showed in the picture, we had a reduced population, established population versus the raised bed. That one then resulted into a higher yield. So if you look at it in this study, several environments, we saw about a 6% increase in using the raised beds. Now, raised beds will also mean you have to have a different piece of equipment. We base this research because this type of equipment is available in the Mississippi Delta, and they have been using this equipment in that region. So that was kind of the background of it. So part of the study also involved applying a chelate to the seed. Now, normally, farmers would apply it either as a liquid or maybe as a granule in the furrow. The difference what we were trying here is to what about if you can apply the chelate right on the seed so you don't have that other equipment and the other things that you needed. So we put the same amount of chelate on the seed what you otherwise would apply in the furrow compared to what the label says. So you can see here on the left is the one with the chelate, and on the right is the line without the chelate. So there is going to be a difference in iron chlorosis. And iron chlorosis is when the plant cannot take up enough iron. So the chelate, bringing it close to the seed, the idea was then you can hopefully have that iron taken up by the plant and you then avoid the IDC. So here just a quick picture. And this one is used by the breeding program to evaluate many of the genotypes that are tested in North Dakota. So just for your kind of scale, I'm going to look here at the next slide of a score of 2.5. So if you look at that one, you see a little bit of yellowing. We do know that if you even have a small amount of yellowing in your beans, it sets that plants back a little bit, and that often translates into a reduction in your yield. So what we did here is having the application of the chelate, or we did have just a regular seed. So what we saw here is that if you use the chelate, for some reason it interfered with the plant development and we had lower stand. I did not expect that one, but that is what happened. So if you look at the last number, you can see that there was a slight increase in yield, not statistically, of the chelate. So there was a little bit of a benefit because if you look here at the number of the IDC, the higher the number, the more yellow it is. So without the chelate, we had more IDC. but in this case, it did not really translate into a significant yield increase. And partly, I think that was because the iron interfered with that on the seed at the establishment. So although the product is really good, the way we were trying it doesn't work really. So the next topic I want to talk about is another way of managing excess water. I've been working quite a bit with tile drainage. And tile drainage is when you put a pipe in the ground about 3 feet down, and it can get the water out of the field a little bit quicker. At NDSU, just north of the airport, we have a research site, we call it Northwest 22, where also the weed scientists have a lot of their work. The blue indicates where my plots were. And the way it was set up is it is a site with all kind of control boxes. And I have 8 units. And the 8 units, I'm just marking one here in the corner. Each unit is about 0.7 of an acre. So just kind of giving an overview. This is the whole field. So you can see here 8 blocks. And you see between where the red lines are, each block has 2 crops, wheat and soybeans, because I rotate them year by year. So within the soybeans, I have several experiments, but half of the blocks represent tile and half of them not. And why can you kind of control it is because we have some boxes. So we have control boxes in the field where you can set the level of the water table. So 4 of them I completely closed to represent the regular rainfall conditions, and 4 of them I set open so that the water table is managed. So if you look at this particular experiment, I worked together with quite a few of my colleagues throughout the US, and we compiled data from my experiments throughout the whole of the US, where we had both data from farmer fields as well as fields that were tiled and non-tiled. So the basic conclusions were that we see about a 4 to 8% increase based on the farmer and the research data. That includes data where we have dry years and wet years, so it is just an average number. It also showed that it appears that when you put in tile drainage, that farmers can plant earlier, and that is probably driving that yield increase. So also based on the data, it kind of shows that tile drainage is a major factor in the improvement of soybean production throughout the region. So just a couple of pictures to show you the difference, and then I'm going to go and talk about some of the yields levels that I obtained. So I have these 8 units, and here I'm giving an example of a unit where the tile is working. I have it open, so the drained, and where it is the tile is closed, you see the water standing into the field. So the system does work. Now, the control boxes are for each unit, so I can set those separately. Then we measure the water table, and I'm going to just show you one water table slide from the past year. Now, the last year was dry. So I'm going to show you here the water table of the no tile is in the red and the tile is in the green. And if you look here, the tile pipe was located about 3 feet below the surface. So this is going from the surface down. So you can see the water table the whole year was below the tile. If the water table is below the tile, it doesn't run, right? So the tile last year did not run, so it should not have any effect on your yield. But what I want to point out is here that what we have seen over the years, and I can show you many of these graphs, that in the beginning of the year, typically the water table is closest to the surface. As the crop starts to develop, it starts to utilize that water, and the water table starts to drop. So this is kind of what we normally see. Well, the next part that I want to show here is the rainfall. So what you would expect is that if you have rainfall, the water table would come up. But actually, you have now 2 factors. You have the rainfall, but you have also the utilization of the crop. So the water table keeps on going down, even if we have a little rainfall. Only at the end of the season, we see that the water table starts to kind of creep up again. So this was in November. So we went into November kind of at a very low water table. So the point is the water table was below the pipe the whole year. Now the issue in our region is that we don't only have excess water, but because of the parent material, we have also issues with potentially salts. And this is a kind of a graph from AgVice where they take the soil samples from the farmers and they look at the electrical conductivity of the samples. And this is the number of samples that come into their office which has an electrical conductivity higher than 1. And that is the critical kind of number. If you have it higher, you will have an issue with crop production. I would say it is even like 0.8, 0.9, you already have an issue. But if you look here at the numbers in our region, you have about 40 to 20 to 40% of the fields potentially have that issue. Now, this next graph is looking at the risk for iron chlorosis. So for those that are guests to us, it is a major issue in our region. We can have soils which are high in pH, the calcium is high there. We have salts included on top of that, and we can get that IDC. So that's kind of the background, and just kind of for your reference, here is the scale again, and now I'm going to talk about scale number 2, roughly. So last year, dry year, we did some experiments, and this one is on the tiled ground. Again, the pipe did not run, so there was equal well, there was no functioning of the tile, no rain in the beginning of the season. So I'm putting here 2 things on the slide. First, I'm putting the IDC score on the left. So again, the higher the number, the more yellow the plant is, and the lower the number it is, more green. So here we have 2 kind of bars, no tile. So there is has not been any tile there for the last 10 years. We see that the IDC was higher than the no tile. Why? Well, I talked that generally we have a salt issue in our region, and because of the time when it was installed till last year, a minute amount of the salt was leached. So less salt, less IDC. But if you then look at the yield here is higher in the tile. So last year, the tile was not running, but the yield on the tile was higher. So this is what I call the residual effect of tiling. So it has nothing to do with the water table last year, because I showed you that was down. This one is the effect of long-term tiling. So I'm doing many experiments on the tile, and here I'm just looking, this is the dry year, 2021, and we see that the no tile is the red bar, on the left is the bushels, the green bar is the tile, and the average is showing that there is an increase in the tile plot, and that was about 11%. Dry year. So some people ask me, you know, if you put in tile, will you have a negative effect on your soybeans? It depends, because if we would completely run out of water, we still may have a negative effect even with tile, but in a situation where we have some rainfall, the tile has some residual effect. Now, the next thing that we discussed a little bit earlier in that paper is that we think that earlier planting is really driving where you get your highest yield. So what I've shown here is the red bar is the no tile and the green bar is the tile. And then I'm looking at 2019 early planting, and we are looking at 2020 early planting, and we see the yield level is that above 60 bushels on the left. If we planted later, that yield level was lower. So in other words, I planted 2 weeks earlier, all the levels of the yields were higher. So why I'm stressing this is because if you look at early planting and you looked at the difference between no tile and tile, so you go as early as you can, now you see a big difference. And in that case, you saw a 28% difference in yield because we could go earlier planting and have more benefit of that tile. So when you put in tile, you can also adjust some of the other management aspects and get some benefit. So in my experience, I've done many experiments sometimes we see, an extra benefit of changing one factor, for instance, at early planting, or some of the genotypes respond a lot better in the tiled. Now, the graph I'm showing here is a long-term that is based on 31 experiments from 2011 to 2021. To make it a little bit easier to show is I'm going here from low yield to high yield. The red bar is the no tile, and the green is the tile, and the bushels are on the left. So if you look at all the experiments, you see that in certain cases there is a big difference with tile. Other years it is not as much. Those were the dry years. So I'm looking here at averages across many years, and we come to a number of 6% here in North Dakota. The first paper that was regional-wise was between 4 and 8%. So this is looking at a general number, but if you can tweak what you do on tile by planting early and using the right varieties, you sometimes can get a high yield difference. So this one is just basically showing that tile does work, and long-term, there will be a benefit to tile. So the next part I want to discuss is a paper we just published on the effect of some of the management strategies. So in our system here, we are planting hopefully around that May timeframe. But if you look here at the light in North Dakota, from May 15th, there's Fargo data, the number of hours of sunlight from 15th of May till the 15th of September. That is kind of our window of opportunity. So if you can plant earlier, you have a little bit more sunshine that you can accumulate, which can translate into the yields. So we are really looking at, can we push the planting date from, like, say, the 20th of May up to the 15th of May? Can you push it a little bit? So the trial that we were conducting, of course, has to do with early risk of the planting season, which is frost in the spring, the latest frost, and then, of course, also the first frost in the fall. So that's your planting opportunity. Now, the past year, we had late frost in May, so it does a number on you. This one is early frost in September. So we can have years where you think you can plant early, and we still caught with some of the issues that can affect yield. So this one was laid out as a combination of early planting, two maturities, an early maturing and a late maturing, and then the seeding rate. And the reason why we got these factors is based on a large survey that we did about 3-4 years ago, where we found that the farmers' data showed that those are important factors. But we only knew them from the individual factors, and here we tried to combine them. So just an example, here this is in Castleton. We have early planted and we have late planted plots, and that is 1 rep. We had 4 reps per site. We had about 21 environments in total. So I'm only going to show you a couple of the highlights here. So here we are trying to plant as early as possible. As soon as we could get in, we planted, and then we planted 2 weeks later. So this is 21 environments. And if you look here at the various yields on the left, and then early planting is the green, late planting is the red, and then we have 19, 20, 21, and the average. So if you look at that one, we saw that early planting gave us a 6.5% yield increase. So this was confirming what we also found from farmer yields. The earlier you can plant, as you can get in, you plant, will have a yield advantage on average, not every time. So the one thing that we also found is if you plant early, we will have a little bit lower stand. So this one is the total of the trial. We're looking here at early planted, the plant population versus the late planted, the population just after establishment. So why is that number a little lower? Well, you plant 2 weeks earlier, the ground is a little cooler, the conditions are a little bit more challenging, and we see that we have a little bit of a stress on the plants, fewer plants established. However, I already showed you that still the yields was higher with early planting. Now, there are other couple of factors, and I'm looking here at the oil. We talked earlier about the importance of oil. Here, early planted gave a slight increase, but significant compared to late planting. Now, the next thing in this trial was comparing early maturing versus late maturing. And we had the two planting dates. So variety early is an 05, is indicated in the red bar. The variety late is in the green bar, the bushels per acre for the various years. Now this one, I'm looking here at 2021. And if you look at this particular Castleton site, you see that the variety that was early out-yielded the late variety. And that had to do with drought. So I talked about the frost issue, but last year we had a drought issue. So what happened is the later maturing was still filling the grain into August, September, but it ran out of moisture. So in that case, the earlier maturing out-yielded. But still, we need to look at over a long period of time. 21 environments here, we yielded 6% higher in the later maturing versus the earlier. Again, that confirmed what we found from the farmer fields. So if you look here, if it is 6% higher, and we had three digit difference from an 05 to an 08, per digit, it would have made about 2% difference. So I'm not saying that farmers should just go out and plant a very late maturing. No, it still needs to be adapted to the region. But if you can plant a later maturing variety, you may get some yield increase potential. Now, the last thing from this study was looking at seeding rate. Now, the seeding rate is not the same as plant establishment. With high seeding rate, we get typically a little bit lower stand establishment in percent. Early planting, we get lower establishment. So we typically in our field see about a 10% difference between the seeding rate and the plant established. So here, the seeding rate was marginally 1% higher. So really it did not make a big difference. But what I was interested in is the combination of those factors. So here we have the factors, early or late maturing, those 4 bars are on the left, the highest yielding, compared to the 05 here is the earlier maturing. The second one is early planting versus late, and you can see in the combination, the early planting out-yielded, and then we see that the higher seeding rate is the left bars. So in conclusion, from my perspective, we should try to plant as early as possible within reason. We need to look at the forecast. If there is frost in the forecast, we probably should hold off on planting. We should try to plant as early as possible with then the maturity rating that is adapted for your region. So again, don't go overboard. And then we could use some higher seeding rate, and I base that on that early planting. We end up with a little bit of a lower stand. So if you increase your seeding rate a little bit, you might compensate for that. So then I want to talk a little bit about another study where we are looking now at intercropping of the soybeans. So the first experiment I'm discussing here is where we interseeded cover crop into the standing soybean, and then we would have a cover during the winter. So that is the idea, is that how can you establish a cover? Should you use wide row spacing, narrow row spacing? Should you use an early maturing variety? Because then you have more light at the end of the season for the crop to develop, the cover crop to develop. And so those are the factors that we were looking at. So, and just a picture here to give you an idea. We had soybeans growing. We broadcasted the seed over the soybeans when the leaves started to yellow. So at the end of the season, broadcast the seed. The establishment of the rye is taking place under the canopy. Then you harvest the crop. The crop develops, it overwinters, and then in the spring you will have some cover to keep the soil in place. So I'm just only giving kind of the summary here. if we are looking at the selection of your cultivar, don't think that you can plant an early cultivar and then you have more biomass. You have more biomass, but the yield reduction is more than that the biomass is increasing. So use a full maturing soybean. Second question was, should you go with a wide row so there is more light for the cover to grow? Or should you go with a normal 15, 14-inch row spacing? And the conclusion was, if you go with wide spacing, you give up too much soybean yield, so it would not pay. Next one, when do you broadcast? We broadcasted very early in the season when the plant was still completely established. The rye will be under the canopy growing, but there is not enough light. So you have to wait till some of the leaves start to drop so there is enough light for the rye to establish. Then we can establish rye late into the season. It is very hardy, but you have to terminate it for the next crop. So we were growing wheat after the soybeans the following year. If we didn't terminate it just before the wheat, we saw a reduction in the wheat crop. So we have to terminate it. And we also do not recommend this system. If you have the cover crop in the soybeans, don't follow it with corn. So the next one, the last one here is about the reverse now. Can you put a cover crop in and then you come back with the soybean? So this is kind of looking at the soybean after the cover crop. So here are some pictures where we used either rye or camelina, and then you grow the cover crop. So this is the last slide. As Carrie says, the fall biomass and the spring, so this is looking at the biomass produced. So we used rye here, and rye produced in the fall biomass. It also produced biomass in the spring. So total, the two together has the highest biomass. However, if you use rye and you put the soybeans into it, you have to control the rye early enough, especially in a dry year, because the rye will consume some of the moisture. So it can work. You can put the rye into the fall into the wheat, but you could also just have spring wheat as a volunteer, and then there is no negative effect on the soybean yield. So with that, I will stop. Maybe one quick question.
Thank you so much, Hans. Does anybody have a question? Because I have a burning one if no one does. So you talked about early planting, which, you know, the early frost on both sides of the season are difficult to manage. But what about going the opposite way? Do you have recommended late planting dates? Like, do not go beyond this date because you will start seeing significant yield losses.
You will start seeing yield losses after you pass the earliest planting date. And that's the answer, because if you look at all the yield data, we have done several trials where you plant as early as possible, you wait, and you plant in end of May, June. We see a yield reduction. So, you know, you can plant into May and still have a fairly decent yield, but you have already given up some yield. So when you talk about late planting, should be only considered if, well, you couldn't get in the field, maybe you still plant, but then you also run into insurance dates. And I don't know exactly the dates, but you know, at a certain point, you also run into insurance issues. You know, if at some point you're losing too much yield,